Hello everybody, this is Yakov Fein with Farada Systems. Today is lesson number 9 from my introductory course on Java programming. Today we are talking about I/O streams, Java serialization, and basic networking. I want to make sure you understand that we are talking about I/O streams, streams of input and output from the Java I/O package, and not about streams from the Java util stream, which is a new API on streams, which is absolutely different. We are talking about input output. Basically, Java program can read sequences of bytes from a stream. What is a stream? It's a source of data, so to speak. If you will open up a stream that points at a file, we are talking about reading or writing into a file. If you will open a stream pointing at a network computer, network connection, so to speak, this will be a stream reading from the network. So, but the idea, the principles are similar to the cases when you read from a file or when you read from the network. Streams considers streams as a source of data where you can read it character by character, byte by byte, or primitive by primitive. And there's a whole bunch of classes sitting in the package Java I/O, and this is what we are talking about today. There is another package called Java NIO, non-blocking I/O. We are not talking about this package during this course. It's a package which allows you to make reading faster. It's a little bit more advanced topic, but for now we are concentrating on Java I/O. There's a bunch of different classes. For example, reader and writer. You use these classes if you are planning to read character streams, texts, or if you are planning to read data Java primitives like double int boolean. If you know the sequence of these data, you can open up data input stream and data output stream accordingly for writing. If you want to work with any files, you can open FileInputStream and read it byte by byte. Or again, file reader, it's about text files. So there are different classes, and you need to look at which one fits your needs and do this and use it. But besides that, you need to remember that there are the same procedure for reading and writing into streams. First, you need to open up a stream that opens at a particular source of data, for example, a file. Then you need to read or write data from or to this stream. When you're done, the stream must be closed. And up till version 7, you were required to close the stream explicitly, and starting from version 7 of Java, you don't have to do this. There's a way to use so-called try with resources, which we are talking about in lesson number 7. I'll show it to you today. But first, let's look at this simple example, which is going to work in any version of Java, even in the older one. Say you want to open up a stream that will be reading a file called abc.dat. And we are opening FileInputStream, as you can see over here, which will be reading data byte after byte after byte in a sequence. And at some point it'll reach the end of file. So to catch the end of file, we declare a Boolean variable EOF. So as soon as we will receive -1 or -1 as a returned byte, for us it's a signal that we reach the end of file. What is this -1? Basically, every byte is represented as a code, as an integer value, and all of them are positive. But the convention is that whenever you hit a -1, it's a signal that it's an end of file. So look at this. What we do over here, we open up the stream, my file variable, and we do read inside the loop while not end of file. Initially it's false, which is the same as not. It's not true, right? So exclamation in the beginning of the variable means negation. So when this end of file becomes true, then end of story. Then we need to leave the loop. And we are reading byte by byte, and we are printing the values. We are printing the value, the code of this current byte, and we attach a space, code space, code space. So whenever we hit -1, we set the flag to true, and this is how we end the loop. And look at this line. I want to draw your attention to this line, closing the stream. Never do this inside the try block. I specifically commented out this line and said, don't do it here with 3 exclamation points. Why? It's simple. If something goes wrong, if we are getting an error, we are jumping out of this loop. Say the file is corrupted, jumping out and jumping over the top of a closing operator and land inside the catch section. So if we wouldn't be having finally clause where we close the file, then the file would remain open, because this is the wrong place of doing closing of the streams. Finally could be the right place to do this if you are using Java 6 or older. If you're using Java 7, we can avoid this section altogether, and I'll show it to you in several minutes. Next, writing into a file is pretty similar, but you're going to be using the FileOutputStream class. Again, it's sitting inside the Java .io package. Say, for example, we have an array, and this array we want to write these numbers, codes, right, into a file. So we have an array. We open up. We create a variable that points at the FileOutputStream. We open up a new instance of FileOutputStream pointing at a file xyz.dat, and in a loop, we are writing the data from the array. In the previous slide we were reading, but now we are writing. And of course, inside finally we are closing the stream, FileOutputStream. You know that all these disks, even if it's an SSD, are slower than operation in memory. So we try to minimize the access to these slow devices or slower devices. So how to do that? Obviously, we don't want to do file read or file access, disk access 1,000 times if you want to write or read 1,000 bytes. So how to minimize access to these devices? We can create so-called buffers. Buffer can read a chunk of data in one shot from the disk, and then your program will be processing it in memory. Then there's the next chunk of data, and again your program is processing them in memory to minimize the access to the disk. How big is this chunk? It depends on the version. I remember like 5-10 years ago it was 400 bytes, and then they switched it to 1 kilobyte. But still, it's configurable. When you can specify, if you're planning to read or write files, you can specify what would be the size of this buffer. And how this whole thing works. The idea is that you can create a stream of one type and pipe it in with a stream of another type. So think of a plumber. A plumber has pipes, so he can take one pipe and add another pipe to it, and another and another. So that's the whole idea. So you can create a file input stream and pipe it in with buffered input stream. So technically you will not be reading programmatically. You will be saying to the buffer, give me the next byte, and buffer inside will see, do I have enough bytes in my, or actually do we still have bytes in my buffer? If yes, it'll give it to the program. Otherwise it'll read another chunk and it'll keep giving byte by byte to your application. So it's pretty simple to pipe these streams together. Like in this example, we open FileInputStream pointing at abc.dat, and this variable, my file, we are giving as an argument to the buffered input stream, right? So we are sticking together, we are connecting FileInputStream and buffer input stream. After that, you do read like this from buff. Please pay attention, not from my file, but from buff. Let this class figure out if the buffer is full or it needs to be replenished, so to speak, with bytes from the disk. That's the difference. So buffering in streams is used only for efficiency. It doesn't change anything. It just minimizes the number of access to the slower devices. What if you need to read character streams? You know, for example, that the file contains characters, text. So you then use specific classes that are created for this, for the characters. File reader, for example, to read characters, and file writer to write characters into a stream. And over here, I read that the recommended way is to pipe the class InputStream with a specified encoding and the file input stream. Let's look at the example. Say we have a string buffer to work with mutable strings. You can use string builder for this as well, but let's use string buffer. So what do we got? We are opening a file input stream, creating an instance of file input stream pointing at abc.txt. Then we pipe it in with the input stream reader. See, this is my file we give to input stream reader. This is already about reading text, characters. The previous line was not about text. It was general file input stream. Now we are going to read characters encoded in UTF encoding. Then we give this input stream reader to the buffer, just for efficiency, to minimize the number of reads from the slow disk. And then we read character by characters. We put this character, one character is assigned to a variable ch, and then we append it to the buffer, which is a string buffer. And then at the end we take when the reading is over, we take the string buffer and convert it to string. Pretty simple, right? Writing into a character stream. Similarly, you open up FileOutputStream and then OutputStream writer. This guy is for texts. And for efficiency, you use buffered writer. So, for example, if you want to record this address, 123 Broadway, New York, New York, you open up a stream that points at abc.txt, pipe it in with OutputStream writer, and then give it to the buffered writer to make it faster. And then one statement, write. Go ahead and do it. Next, walkthrough number 1. So we're ready to do this. So you will need to import the lesson number 16 from the textbook, from the WROX website that accompanying the book. And that lesson was created originally like 3 years ago. It was created using JDK 1.6. So you would need to go to properties of your Eclipse project and change the compiler to use JDK 1.7 and change the build path to use the latest one, 1.7 Java runtime. It's going to work actually with 1.6 Java as well, but I started making some changes which don't exist in lesson 16. I'll show it to you now, which require Java 7. Try with resources was not available in Java 6. So we will open up that project. We will look at this code text file input stream, text buffer input stream, and we will make a change to put opening of the file input stream and buffer input stream inside these parentheses in try block. It's important. When you put it inside the parentheses, you are creating a try with resources situation, right? Which says that you don't need to close these streams. They will be auto-closable. If you don't remember what it means, please re-watch the lesson number 7. And I'm going to use a couple of new versions of these classes that don't exist in lesson 16. And at the bottom of the slide, you see where they are. I started creating new samples, little samples for the Java For the second edition of the Java book, actually, Wiley asked me to do the second edition of the book, and I will start working on it next month. Obviously, it'll include brand new chapters and brand new features of Java 8. But for now, just get these. There will be 3 examples that you will need. I'll show it to you now. So I already have this lesson 16 in my Eclipse. I already imported it. So test file input stream. It's the same program as you saw on the slides. See this? File input stream, you create it in a loop. You're looping through it, reading through the file. When it hits -1, you set the flag to true, and then finally you're closing the stream. By the way, check this out. The code is pretty convoluted in this notation, in the pre-Java 7 notation. First of all, you need to check if my file is not null, right? So you were opening it up over here, but what if this failed and my file is not initialized? So you need to check for that. Then if it's not null, then you close it. The closing has to be placed inside its own try-catch block, because the closing can give you a problem. So it's piling up, so it's not pretty. This code is not pretty. And what is better, look at this. There's a program that ends with 7. Again, it's not in the book, but it's in that, you can find it in the link that was on the slide. It ends with 7, meaning that this version will work in version 7, Java 7. Check this out. A small change, I just opening up file input stream, not inside the try block, but inside the parentheses after the keyword try, which means try with resources, which means I don't have to even close the finally block, close the file in the finally block. Let's compare these 2 files. By the way, to compare files in Eclipse, click on one, click on the other, and right click here, and there is a very compare with. Compare with what? I want to compare with each other. See? And it creates for me a comparison side by side. Test file input stream and test file stream. This is a test file input stream. This is a test file input stream 7. Look at the difference. Line number 6 over here. This is how I do my new file input stream. And over here, I do file input stream not in parentheses. It's not try with resources. On the left-hand side, I have this convoluted code for finally. Over here, I don't even use finally, right? So this code is much more elegant and simple and short. So use try with resources, because it does your body good. Now, test buffered input stream, adding a buffer. Again, it was on the slide, the same reading the ABC, but pipe it in with the buffer input stream. Right click, run as. It prints the content of the file abc ... which is over here. Now, one more thing again. Version 7 is much more elegant. Why? Because I'm opening these 2 guys inside the parentheses. Try with resources. No need to close this. No need to close file input stream. No need to close buffered input stream. And finally, text GUI file. Text GUI file. It's a little GUI program that reads states from this text file and populates the combo box, the drop-down. Let's run it first. Right-click, run as Java application. That's the beauty over here. Select state. All these data were read from states.txt and placed inside the GUI. So we are bringing together all these little pieces of knowledge that we have, how to create UI, how to populate the drop-down, and how to get UI from the file. And now we can do everything together. And populate states is the method, line number 92 over here. And this example was created again before version 7, so we are opening file input stream that points at states.txt. It's right there. And input stream reader and buffered reader. And we are reading line. So when you read lines using the input stream reader, you can read 1 line at a time. You don't have to read 1 character at a time. And this the version for the Java 7. Again, similarly, I use drivers resources. All these three streams were opened inside the parentheses into the try block, and that's why I don't need to close anything. Life is good. No final statement over here. We are done with walkthrough number 1. Files API is also useful, and Path API is useful. Files API has a bunch of Files API has a bunch of useful methods to create, update, delete, and copy files. Path API is a programmatic representation of the path system, because path in different operational systems looks differently in Windows and in OS. So you can you need to read about these two APIs, two classes, and you may find something useful in there. For example, Files API allows you to read all lines in one shot. Maybe you'll find something else, or read all bytes in one shot. So pay attention to these two classes. They are pretty useful. So we are done with the first section of the lesson. We have 2 more to go. Java serialization. What is Java serialization or Java object serialization? It's a case when we are turning an instance of a Java object, say customer or tax or employee. We are turning an instance of a Java object into a stream of bytes, into a sequence of bytes. What for? To send it over to another JVM, to another application that needs to do the reverse operation. It needs to read the sequence of bytes and recreate the instance of that customer or tax as a Java object in there. So we are turning it into a stream of bytes, an object. Or we are deserializing, reconstructing the object from the stream of bytes. Again, keep in mind that now we are talking about Java to Java serialization. One Java virtual machine can serialize data and send it over to the other Java virtual machine. How it can serialize? The simple case could be it can serialize it into a file. Somebody can send over the file to another location, and the other application will read it and deserialize the data. Or you can serialize it into a network stream, so there is no need to use intermediary file. Or you can use it with technology like Java Remote Method Evocation, RMI, or you can do it over sockets. We will be talking about sockets and RMI later in this course, maybe in 2-3 weeks. Let's look at the sample use case. Say, for example, you create an instance of the class tax, populated it, obviously, last name, first name, state, income, dependents, and then you can serialize it into a sequence of bytes. And then you send it over the network, that sequence, using this process is called serialization. And on the other end of the wire, the other application will deserialize the object text and recreate it as an instance of Java object. You can say, why do you even need it? Because it's convenient, because it means that application A in our location and an application B in the remote location don't need to come up with special rules of how to send data back and forth. What kind of data? Instances of the objects. Say, if I would have my colleague Mary overseas, and I would say, Mary, I want to be sending you the data from the Java instances in my application. Mary would have said, how am I supposed to read it? Can you explain me what fields are there in your class text, in which order? And then I'd say, Mary, don't worry about it. We don't need to think about it. I will take the instance and I will serialize it into a stream of bytes, and you will just recreate it over there. What is important though, Mary has to have the definition of the class that we are serializing. If I'm serializing class text, which has a structure, certain fields, this class text has to be in that application that Mary runs. And they have to match. And I'll spend another couple of minutes on that a bit later. How to make a class capable of being serialized? The class needs to implement serializable interface. Again, let's go over scenario. A class A creates an instance of the employee, which has the fields first name, last name, salary, and so on. The value of these fields, again, in the instance of an object employee, have to be saved in a stream. Stream and go to Mary. A class B that runs on Mary's machine, it needs the data about this employee. Maybe it's an employee of the month, and this employee of the month is supposed to be parking his car right next to the door to the building. Why? He's the best employee. Not kidding. So that application has to recreate the instance of employee in that JVM. So let's look at this example. Class employee implements serializable interface. It has last name, first name, salary. And when you look at it, something should be, you may say, something doesn't look right. And what is this something? The fact is that I don't see any methods that are implemented. Remember how we said interfaces are like contracts between the class that implements this interface will definitely implement all the methods that are declared in the interface. And where are these methods? And the answer is there is no methods to implement. Serializable is one of these interfaces that are so-called marker interfaces, which means that there is no methods to implement. Just say that your class implements the interface and that's all you need to do. So what's the point, you can say? The point is that you are saying to compiler, you're saying, dear compiler, this class will need to be compiled in a certain way so it can be serialized. And compiler knows how to do this, how to produce the proper byte code for serializable classes. It'll add stuff to it. And how you're gonna serialize the instance of this object? Easy. You will open up a stream, but of a special type, ObjectOutputStream. If you will be serializing, or if you are deserializing an object, then you will be opening ObjectInputStream. So far, so good, right? Let's look at the code example. ObjectOutputStream. We have a class A, and we want this class A to serialize an employee into a file, into a local file that will be called best employee ser. I decided to call this ser. So to serialize an object, you need to open the output stream. You need to, in our case, it's a FileOutputStream, right? To point at this file which we are planning to record, to write in. Then we need to chain it or pipe it in with the ObjectOutputStream, and this guy is specifically fine-tuned for serialization. And then we're going to call the method writeObject, and this is it. And we're going to say, we're going to give an instance of employee to this writeObject and say, do it. And it'll do it. And close the stream, of course. So let's look at the example. You create an instance of an employee and you populate it with the data, with a value. It's the state of the object. John Smith, 50,000. Then you open FileOutputStream, ObjectOutputStream. See this guy? We are opening FileOutputStream and give it to the ObjectOutputStream. And then we take this EMP, which is serializable, by the way, and we give it to the method writeObject. Done deal. That's it. The whole instance is remembered inside the file. It's stored inside the file, best employee ser. By the way, pay attention to this. I don't know if you've ever seen these double backslashes over here. The thing is, the double backslash in Java represents a single backslash. Kind of sounds weird, right? But the thing is that there are so-called escape characters. If there is a backslash and a character, backslash p or whatever, it may be treated differently. It may be treated as a special command to do something. So to say that backslash is a backslash and nothing else, remember Winston Churchill, sometimes pipe is just a pipe, right? So you need to put two slashes together, saying it's just a slash, no escape characters, nothing, don't worry about it. Done. That's how you serialize the object. How to deserialize the object. How to read it back and recreate it, resurrect the instance of the object from ashes, so to speak. Open an input stream. Chain it with object input stream. And now call the method read object. In the previous slide we were calling write object, and now we are reading object. What is important that on that end, in that Java runtime, when you are deserializing the object, the definition of the object should be there available too. So the declaration of the class employee should be available in both applications. And you will be casting to the employee in our example. And you need to close the stream. So let's see. Now you open up a new file input stream, right? And you pipe it in with object input stream. And then you say read object, and you have to cast it to the class employee. And we need to have the declaration of this employee over here. That's about it. Done. Done. What else I want to say over here, if anything? Nothing. Simple. The transient keyword, transient. In some cases we want to serialize an object which has multiple fields, but we don't want to send all the data to the other end, to Mary. For example, salary, of course salary is a very sensitive information. Nobody wants to know what's your salary, right? Not even your wife. Does your wife know your salary? Big mistake. So what do? We just add this magic keyword, hide from wife. No, transient keyword. If you will do that in a, say this was a line inside the employee object, then the salary value of the salary will not be serialized. The whole structure of the employee will still go over the wire as stream of bytes, and it will be recreated over there. But if over here we had the value of salary $200,000 a year, on the other end it will arrive as 0. Default value for this type double. So the data will not be serialized. In some cases, transient is not used just to hide the value from your wife. In some cases there are different reasons. For example, there is no need to serialize some data, like when was the instance of this object created. Maybe there is a field that remembers that inside the class definition. When it'll write over on the other end, it's useless information. Or maybe in this object it remembers some specific information about connectivity with the database. On the other end, it's different database, it's not needed. So if you don't want to serialize certain field from a class definition, just mark them as transient. Serialization and versioning. I already mentioned this 10 minutes ago, let me do it again. If a class employee here and there, if there is a structure of an employee that looks like this, 3 fields, last name, first name, salary. In both ends, Mary has it, Mary has a little m, and I have a little m, and they are the same little m. What if I will decide to add another field on my end? Mary has no clue about it, right? So what's going to happen? So we have a situation when my employee has a different version than her employee, and we got a problem. To make sure that we can control the versions, there is a special variable, serial version UID, unique identifier. If in the class employee on my end I want to make sure that I can control versions, I can declare this variable and I can give it a name. Oh, sorry, not the name, the value. Any value, in this case 1, of type long, right? I gave 1. And I send the same version of employee to Mary, and she has employee to Mary with this extra line with serial version ID 1. Now, 6 months later, I decided to add some fields to the employee definition, and being a nice guy, I change the serial version ID to 2, just to remember that I changed something. So next time, if I will forget to give Mary the new versions for employee, actually maybe I'm not around, and maybe I don't work in this company anymore. I just made a change and left. I am freelancer. I don't give a damn about this code. Then Mary's code will break. Mary's application will break. So if I'm using versioning, right, this exception which Mary will get will give her a hint, invalid class exception, that something is wrong with the definition of the class that she's trying to deserialize. She's gonna give a call and I will ask, guys, what's happening? Yakov promised me not to change anything, and they say, sorry, Yakov is not here anymore. He moved on with his life. Give me your version of serial version ID. She says, I have still one. Oh, then you have outdated version of employee. Let me send you over a new employee definition and recompile it, and now everything works again. That's what it is for. I'm sure that some of you maybe even saw it when you generate classes. Sometime Eclipse ID inserts this line, and you didn't even know why it does it. There's a way to turn on this generation of this line in Eclipse, but this is what it is. Now you know the secret. Workshop number 2. Lesson number 16. No, it's 17 from the textbook. And we will look at the serialization and deserialization. Lesson 17 already imported into my Eclipse IDE, and let's take a look. Employee, that's exactly the same as we have in the slide, on the slide. Class A will serialize it. A new instance of employee, John Smith, 50,000 salary, and we open up a stream pointing at a file best employee SCR, and we are creating a new object output stream, and then in the end we are closing. Again, this can be changed for version 7 of Java to use Travis resources. Run the Java application. The employee object has been serialized into best employee SCR. Here it is. Looks like gibberish to you, right? But if you will take a closer look, look at this. It looks like a F name or something. Salary over here, right? It looks like some values over here. Some encoded way for Java to present a serialized version of the type. Class B will deserialize the file. It'll open up the same best employees that we just created, and it'll create an input stream, and it'll call the read object on it, right? Read object on it, and it'll cast it to the employee. Luckily, we have the employee definition over here as well. Then closing streams. One thing that I didn't notice, I didn't mention, by the way. Did I? I didn't. Flush. I don't think you saw it at all. I don't know why they didn't even put it over here. But basically, the idea is when you are reading using buffers, you need to do a flush, like flushing the toilet, right? To make sure that no bytes are, no leftovers remains inside the buffer. So everything went into the output stream. I don't even know, to be honest with you, if it's still required in the latest version of Java. Maybe not anymore, but well, I've been doing it 10 years ago. I still have it. So that's the thing that's done. Did I run this class B? Let me run this class B. Run as Java. Employee object has been deserialized from there. It works. Check it out for yourself. And one more thing to finish up with this serialization. It was really nice, right? Just one method call and the whole object was turned into a stream of bytes. Just write object and the whole thing, last name, first name, salary, was turned into a stream. And on the other hand, read object and the whole thing is back into memory, into heap memory. So what's wrong with it? There is something wrong. What if you have a large class with many fields, 50 fields, and technically you don't need to serialize all of the fields. You want to serialize only some of them, to minimize the footprint, because there is no free lunch, right? If you have 50 fields, and if you have 10,000 objects or 1,000 objects of this type, and you need to serialize all of them and send over the wire, each of them will have pretty large footprint, a sequence of bytes. What do you even need to serialize all 50 fields? Like more than 10 years ago, 12 years ago, I was working for a company, brokerage company. We were doing trading. So you're sending a trading order to the stock exchange, and the trading order was represented as a class with 86 fields. All these are important parameters for a brokerage house, of course. But the stock exchange didn't need 86 fields to place an order to buy 100 shares of IBM. So we wanted to serialize only, say, 10 out of 86 to minimize the size of each serialized object, because we were fighting for milliseconds. Speed is the king on Wall Street, right? So instead of using serializable interface, which is easy, of course, but it doesn't give you any flexibility. It doesn't let you specify which fields you want to serialize. We can use so-called externalizable interface, which is a sub-interface of serializable. So it allows you to write specifically, to implement methods write external and read external, where you would be saying which fields you want to serialize. It'll require you a little bit of more of coding, but at least you will have a chance to serialize only what you want and not everything. This is how it goes. It's a different version of our employee class. It implements externalizable now. Now it has more fields: last name, first name, address, hire date, ID, and salary. 6 fields. But we want to serialize only 2 of them: salary and ID. So for that, we are overriding write external. Accordingly, to reread the file from the stream, we will be overriding read external. In the write external, we say, I want to write only the salary and the ID. Write double salary because salary is double, and write int because ID is integer. And accordingly, whoever will be deserializing the object, they will need to read in the same order. Right, so they would be giving the stream, so they will need to read first the double and then the int. This small change in the employee class will allow us to serialize a smaller number of fields for each instance. So how do you do this? Created an instance of employee, populated all 7 fields, but we don't care. We care about ID and the salary only. Still open up the file output stream, create a new object output stream. It's still the same, and you're saying now serialize me that employee. You still do write object, right? But employee is a bit different now. It has overridden method write external, and only this will be executed. Only 2 fields will go into a stream. So you got the point. That was Java serialization. And one more thing to mention. Today, when we are talking about the applications that are written in different languages, the word serialization is used in different contexts. In our case, it was Java to Java serialization, to use something that exists in Java off the shelf. There is nothing else to be done. But what if you have Java on one end and the HTML5 JavaScript on the other end? Typical situation: a web application, HTML5 talking to Java on the other end. So in cases like this, an instance of an employee, plain old Java object on the server side, can be serialized and turned into something that browsers should understand or JavaScript engines should understand. And what do they understand off the shelf? They understand JSON. It's a special format in JavaScript. So you could be using either Java EE feature, Java Enterprise Edition feature, to create JSON out of Java instance. JSON is also a string, but in a special way. It's formatted in a special way. Or you can use a third-party library. So in this case, we also can use the word serialization. The instance of Java employee is serialized into JSON and sent over to the web client. But it's, I just wanted to make sure that you understand that the word serialization is used throughout the software industry, and it could be done from one language to the other as long as both parties understand the data format for serialization. And finally, the final section of this lesson is network programming with a particular class called URL. By the way, Java.net has a whole bunch of useful classes to do different type of network programming, but we are focusing on one and only URL. Actually, there will be URL connections as well, but they are sitting in this Java.net package. The whole idea is I want to see if I can read data from the internet, open up streams pointing at the internet and read data from there. Some terminology which most of you probably already know. There are different protocols. People talk to each other using different languages. At this moment I speak to you fluently in English, right? So we can say that English is the protocol for this lesson. Yesterday I recorded the same lesson in Russian. Yes, I speak Russian. Я говорю по-русски. So yesterday I was using different protocol. It was Russian. Now, when we talk about computers, it's also the same story. Computers talk to each other by using certain protocol. And if both parties understand this protocol, then they can talk. In particular, we concerned with HTTP, which is the protocol of the web. So a browser makes HTTP requests to the server. Server gives HTTP responses to the client. So let's just remember that HTTP is one of the protocols. Couple of more terms. LAN, local area network, is a network between computers which are located close to each other, maybe on the same floor, maybe in the same building, in the same company, so to speak. Wide area network is a case when we have computer remote. They are not located nearby. There is no wire, unless you will count that thick wire that goes under the ocean. There is no wires going inside the same building to connect these two computers. Wide area network. World Wide Web. Have you ever heard of www? I bet you heard. So World Wide Web uses uniform resource locator, URLs, to represent resources on the internet. For example, over here I have this beautiful resource. Training HTML is a file, maybe a file, located in some server that is represented by domain name mycompany.com, and we are going to that domain name through the port number 80. Port number 80. What are the ports? Say there is a building, many apartments in the building. The building has an address. Address is mycompany.com. But what's an apartment number in that building? Say 80. So one server can have many doors, so to speak, ports. And by default, port 80 is the one that is being used to connect when you are using HTTP protocol. IP addresses are the unique combinations of numbers. It can be either a combination of 4 numbers or a combination of 8 numbers, which is uniquely identify a computer at this time. These IP addresses can be dynamic. If you are not a big shot, if you are not an enterprise, a company, if you're not paid extra money to have assigned for you specifically an IP address, then if you're a regular guy who is connected to the internet through some internet provider, then most likely the internet provider assign you so-called dynamic IP address. It's not the same. It may change tomorrow, But do you care? No, you don't care, because you are not running business. You are not running server with unique ID, with unique IP address that has to be mapped by some name, like mycompany.com. If it's important for you, then you purchase the name, and then you purchase a static IP address, and you map the name, DNS, right, domain name service, to the IP address. And how the whole thing works in the internet, when you enter www facebook.com. All internet providers around the world have this database, access to the database that maps DNS data name, that maps names with IP addresses. So it'll go and quickly find the main server of Facebook, and of course behind that main server, the Facebook has thousands, literally tens of thousands servers, but that is the problem of Facebook already. But anyway, when you hit facebook.com, which I hate, I think Facebook kills the young generation, make them helpless and not ready to work and live in the real world, but that's beside the point. This is how it works, and you need to know it. Reading with java.net.url. So let's try. A couple of more things. HTTP URLs that start with HTTP goes through port 80. URLs that start in secure way, HTTPS, they go through port 443 by default. And of course, this course is not about writing web application, but I highly recommend you to not use HTTP at all. Always use secure encoded communication. So before the data is being sent from the browser to the server, the browser encodes the data in a special way. Next, how you do this? How you work with this remote URL? Since we know streams, can we use streams with those? Yes. Create an instance of the class URL. Of course, you need to give it a URL, like google.com. Then you need to create an instance of the class connection and say to this URL, my friend URL, could you please give me connect me to that google.com or whatever else you want. And then if connection is successful, then you will say, dear friend, my dear URL connection, I need a reference. I need a pointer at your stream, because I know how to work with streams. Give me the pointer at your input stream. And if this line is successful, I got a reference to your stream, and after that, I'm the king, because I already know how to work with streams, right? And it's the same as if you would be reading a stream that points at a local file. The same. And then you start reading the data from this stream. Of course, use buffered reader if it's a text field. Sorry, if it's a text stream and you want to make it faster. So the whole story remains the same. The only difference is how you get a hold of this input stream. And if you want to read the content of HTML page from google.com, for example, what do we do? And we'll try it now. Hands-on. Website reader, there is a class in the lesson number 17. So what do we do? Main, do you know what is public static void main? I hope you do by lesson 9. So what you do, you declare a URL variable and URL connection. You declare input stream reader, and you want to pipe it with a buffer reader. Fine. Buffer reader reminder is for texts only. So what do? We say URL. We create an instance that points at the URL. www.google.com. By the way, I am catching over here malform URL exception, which may be thrown when, not if the site is down. Google is down. Can even this be the case? It's like end of the world. It can be probably in the location near you, but this exception is thrown not if the Google is down, but if you misspell the URL, you put a weird letter in the HTTP, for example, HSTP. Malformed URL, there is no such a thing. Anyway, you create an instance pointing at a URL. It could be just google.com or maybe google.com/name of the file. Then you say to this URL open connection, and then you say to this connection, get me the input stream, dear connection, in the encoding UTF-8. Actually, sorry, we are saying I want to create an instance of input stream reader. Here is your connection, and this is the UTF-8 encoding. Then we are saying, dear buffered reader, I want to read as fast as possible. That's why I'm giving to you this in stream. Then in a loop, we are reading line by line because we know it's a text. And finally, we are closing the in stream and buffer. That's all. That's all there is to it. Let's try to do it. Walkthrough number 3. We are opening lesson number 18 in Eclipse. And then we look at the website reader and we'll run the program. Then we'll review the output on the system console. Lesson 18, which is right there. Website reader. I'm connecting to the Google, opening connection, input stream reader. Exactly the same thing as on the slide. Run it. See this? Wow, that's what it is. That's what's coming from google.com. Doc type HTML, HTML code, JavaScript, and everything. It's minimized, so to remove all the extra spaces. Not minimized, minified. It's minified. But anyway, as you can see, it's HTML file with some scripts. Is this a magic or what? We know what the Google's page consists of. I don't know if it was HTML file statically created or Google creates it dynamically on the fly. When I hit google.com, it's beside the point. I can read it. Now, actually we did already walkthrough number 3. No. Finally, what we will do one extra little thing. We will see how we can download files from the internet using the same exact thing, using that URL class and URL connection. Say we know a file, we know a URL of the file, and say this file is not protected in any way. No login, nothing, no authentication. So if I can provide a URL to this line, create a new URL, and if it doesn't stop me, then I can read it and I can download it. How to do that? This little program expects you to provide 2 arguments, command line arguments. Remember, what is the URL that you can get, that you wanted to get the data from, and what is the name of the file, local file, where you want me to save it. So arg0 will be a URL of the remote file. arg1 will be the place where we want to write, download. So what do? I say URL, please connect me to that URL that was provided on the command line. Then I say, let me try to connect to this remote file. Is it working? Hopefully yes, if the file is not protected. And then what you do is you create a file output stream, because you're going to be writing into this file that provided as a second argument on the command line. And then you will say to the in file stream, we are pointing at a remote file, right? I'm saying your URL connection, please give me a reference to your input stream. I want to read you. If we get a reference to the thing, what I do, I read byte after byte after byte, like we did in the beginning of the lesson. It was a stream pointing at a local file. Who cares? I have a stream. I can read it 1 byte after the other. So what I do here, I said in.read, that input stream. I put it in the variable data, and if it's not equal to -1, if we didn't hit the end of file yet, then I take this piece of data and I write it into output stream. Put it right there, fout is the local file where I want to write the data. So it loops through the byte, and when it's done, it's done. I have the local file that was downloaded for me byte after byte. Important thing to remember and understand, this program does not care what format is this data in. Is this MP3 file? Maybe it's an image, it's a JPEG or PNG. This program doesn't read, and it's not supposed to read. This program is supposed to download the file. Then if it's an MP3 file, then you can obviously double click on it, and if your system knows what to do with MP3 files, it's going to start playing it. And that's exactly what we will do. That's exactly what we will do. It's a mistake. It should be a walkthrough number 4. I need to fix it. So what I will do now, I am recording audio podcasts in a site called america.us. It's podcast of my life in the United States of America. But I record them in Russian, so if you don't understand Russian, so don't even bother trying to listen. But that's besides the point. I'll show you how to download it. And you can download it. You can download other files similarly if you know their URLs. So what we will do, we will just look at the program file download Java, and then we will run it. Right? And we need to specify 2 parameters. What do we want to read? And we need to specify where do we want to save. So file download, that's the one. Let me clean the console. File download. So I need to specify 2 parameters. The URL of the file to download and where to save it, right? So I already did it in here, but let me show you where. Right click, properties. Sorry, not in properties. Right click, run configurations somewhere here. Lesson 18. Oh, it's not configured. Let me do that. I want file download to be my runnable program. All right. Now arguments. Do we have anything? No, we don't have anything. So I need to do everything from scratch. So let me show you how to do this. I want to read my podcasts from this website. So I need to find out the URL of the MP3 file. And I will specify the name of the file to download. Let me show you this URL. Again, don't be scared from Russian language. Not all Russian people are aggressors who want to invade Ukraine. Some Russian people are really, really nice guys. So that's the URL, right? So what do we want to do? So these are the URL, these are the podcasts, and what we can do over here, look down there at the very bottom of the browser. myflex.org, yf, podru, budam, 421 mp3. It's number 420 already. I already recorded 420 podcasts. Can you imagine? So there's the URL. Let's take the fresh one. This, by the way, this one I published today, if I'm not mistaken. Yeah, today. All right. So what I will do in Eclipse, I will go and I will say I want to download myflex.org yf. That's the file that I want to download. And where do I want to download it? See, I have a best podcast over there because I did it yesterday. Let me do this. Let me give it a different name. Best podcast March. What's it? March 29th. So I want to take this remote MP3 file and download it in the file with this name. Let me do apply for now. Now one more thing, this line I already did, is the walkthrough says add this line. So this part is done. The next line says add this line system out println downloading. I already did it over here. So it'll tell me that I started downloading. So let's run it and see if it will work. Come on, I already applied to the, what happened? I thought I saved configuration. Run configurations. Lesson 18, file download, of course. Argument, that's correct. What else do you want? Run. Yeah, it says downloading HTTP my flag, blah blah blah. So it works. When it's done, it'll print a message. So at this point, it keeps reading file byte by byte. I don't even know if I created the buffer stream over here. I didn't, which is a mistake. It's more than 20 megabytes, so it'll take maybe another 10-20 seconds. And when it's done, we'll see a message that file so-and-so has been downloaded successfully as a name of the file. Let's wait. See, it's done. It was downloaded successfully as bad podcast March 29th. Let me refresh the project and we'll see it over here. Right click, refresh. Here it is. There's the guy. That's the MP3 file. Did I call it MP3, by the way? I probably didn't. See, the other one I called MP3. If I will double click on it now, nothing happened because it doesn't know that it's MP3, my computer. Let me rename it. That's my mistake. Rename it into March 27 MP3. So it'll know to open iTunes. All right. Double click. See? It started playing. It works, guys. See, I just now downloaded a file, MP3 file from the remote machine. So now you know how to do things, and I am sure that you will respect the copyright and will not start immediately downloading all these illegal content. We are done for today. Please do the homework if you want. If you don't want, don't do it. I'm not going to call your parents to come to school. So use modify your code from lesson 16 to use try with resources as explained in lesson number 7. I already did it actually. I even gave you a URL, so you have nothing to do there. Do the assignment from the try it section from this lesson 17. And for extra credit, which I will never even know if you did or you didn't, what I want you to think of or try, it's not rocket science. What if you want to download not just one file, MP3 file, but several of them? Can you zip them up after downloading? So this is something to consider. And finally, additional materials. Read them if you like. Tutorial on working with files from Oracle, tutorial on working on serialization from Oracle, and nice article about serial version ID. All these can be handy. And thank you very much for watching. This was Yakov Fein with the company Farada Systems. We do web development, Java development, you name it. We do everything and we do it well. Thank you for watching.